Greetings, Weather and Climate Geography 306. This is the first of 4 videos looking at temperature. Uh, this is Unit 1, Module 4. And remember that heat and temperature are related concepts. Heat is essentially the kinetic energy of a substance. It's the vibrating molecules. Temperature would essentially be a measure of the intensity of that heat, like how fast the molecules are vibrating. That would be the best way to distinguish the two. So remember, you can have a very small amount of a substance with an incredibly high temperature, but there really isn't that much heat. Or, for instance, you can have the entire ocean at a lukewarm temperature, but collectively that would be a lot of heat. So, as always, we follow the notes here. And the first point I want to make is just looking at different types of measurements. And we'll take a look at thermometers and what they measure. But there's kind of 5 classic measurements that can be taken and that are commonly referred to when people collect this type of information. So the first one is the daily mean. If you say, what's the temperature today? Well, the temperature is going to change during the entire day. You might say, what's the high for the day? You might say, what's the low? The mean is really the average temperature for the entire day. And it can be taken once per hour and then have an average taken. So you would add up 24 measurements and divide by 24. Or another quick way to do it is to take the maximum, the highest, add the lowest, and divide by 2. So take the average of the highest and the lowest. It turns out both of those measurements generally often come in pretty close. Okay, so the daily mean, the average temperature for an entire day. Put one number on an entire day. What about the range, the daily range? This is really important to understand. It is not a temperature. It is a temperature difference between the maximum and minimum, the highest and the lowest for the day. And this is really important because a high daily range means that there were generally extreme temperatures during the day, that the high got pretty hot and the low got fairly low in comparison. A low daily range is not a low temperature. It's just a very small difference between the highs and the lows. It means things didn't change much. So if you have just lots of clouds for 24 hours, you generally have a very low daily range. In the winter, if you have incredibly clear skies during the day and it warms up a little bit, and then clear skies at night, it gets really cold, then you would have a high daily range. So you got to make the distinction between those two. Monthly mean is if I can put one number on an entire month, you just take the 30 or 31 daily means, or maybe it's February, you add those up and divide by the number of days. So you just take the number for each day, the average for each day, add them all up and take the average. The annual mean, so the mean for the entire year for a given location, you would just take the monthly means, add them up, divide by 12. And then finally, the annual range. So remember, the daily range is the max minus the min just for one day. The annual range takes the highest monthly mean, average, same thing, minus the lowest or the coldest monthly mean, and it takes the difference. So please remember, range is difference. And we are going to see this in action as we look at some of the data. Some places have, in general, a very high annual range. It means they experience extremes. Highs are pretty high in the summer, lows are pretty low in the winter. Some places have a very low annual range. The temperatures don't change that much during the course of the entire year. Around here, we would compare Sacramento and San Francisco. Sacramento has a much higher annual temperature range. San Francisco, over by the coast, highs aren't that high, the lows aren't that low. In comparison, we would say San Francisco has a low annual temperature range. So, mapping temperatures. Let's jump over to the slides. And here are 2 different types of maps to show temperatures. In your notes, you see the terms for these. The Chloropleth map. Chloropleth is a reference to colors, a range of colors, or an isotherm map. So for a minute, let's take a look here. This is one that many people are familiar with, and it uses a color to represent a range of temperatures. So this reddish orange is in the 90s or higher. This orange here is in the 80s, so from 80 to 89, and so on. This range is in the 70s. So you can see they've used what's called a color palette that is fairly traditional. We often experience oranges and reds as warmer temperatures and purples and blues as colder temperatures. So it turns out that if we look at the lines that divide the colors, they are essentially the same lines that we see here. In fact, this chloropleth map is showing the same data as this isotherm map. So what's an isotherm? An isotherm is a line connecting points of equal temperature. So that is, this line right here is the 80-degree Fahrenheit isotherm. The line down here is the 90-degree Fahrenheit isotherm. You see these lines are the same as the lines shown here. So we'll look a little more into just how this is done. You get a sense, actually, when you look at the weather stations that are reporting here. Here is Louisville, Kentucky, reporting 66 degrees Fahrenheit. Well, 66 lands roughly halfway between the 60-degree isotherm and the 70-degree isotherm. So this is how you actually draw these lines. If you ever take a physical geography lab class, this is one of the activities that we will do. So you can see the same thing basically in all of these, that the temperatures reported should be consistent with the isotherms. So here's Bismarck, North Dakota at 19 degrees Fahrenheit, very close to the 20-degree isotherm, but not on the 20-degree isotherm. Here's Fargo at 23, roughly halfway between the 20 and the 30, and so forth. So you should be able to look across this entire map and understand that the lines were drawn essentially between weather stations that are reporting different temperatures. So one of the other things that I want to bring up with regard to chloropleth maps and isotherm maps is the idea of a temperature gradient. And gradient just means, in science, it often means change over time. It can also mean change over distance. So in this case, we're looking at a map, we're talking about amount of change over distance. And what we do is we look at how closely the lines are spaced together. So in this case over here, the lines are incredibly closely spaced together. That's a 10-degree change every time you jump from one line to another. So we're here in southern Arizona, and it's in the low 70s where my cursor is, and suddenly I get up here and it's actually in the high 40s. In central to northern Arizona, up by where the Grand Canyon is. So we would say this is a high temperature gradient. Lots of change over a short distance. So let's just say we take this short distance right here. So I'm tracing back and forth this distance. And let's say I go to an area like up here, okay? That same distance, the temperature might change only 1 degree. Here it's changing 20 degrees. So maybe this is 100 miles. I don't know. I don't have the scale in front of me, but I'm moving the little red dot back and forth. So maybe that's 100 miles, 1 degree per 100 miles. In this case, it would be 20 degrees over the span of 100 miles. So we would call this a low temperature gradient with widely spaced isotherms. Again, down here, this would be a high temperature gradient with narrowly spaced or closely spaced isotherms. By the way, iso means same, therm means temperature. So that's why it's the line of the same temperature. So you should be able to give me an estimate. If I ever give you one of these on an exam and I put a dot, let's say right there, you should be able to give me an estimate of the temperature. Well, the red dot, okay, think about it, maybe pause the video for yourself. What is the temperature at this point? Okay, now that you've unpaused, it should be about 75. Let's go here. What is the temperature at this point? Okay, pause. Okay, now that you've unpaused, it's pretty close to the 60. It's closer to the 60 than the 50. So you would probably say 58, 57, something like that. Okay, so let's jump on to the next topic. Looking at temperature change over the course of a day. Okay, so we want to take a look at what the patterns are, and we also want to take a look at what causes those patterns. So here is just a sample from Chicago, Illinois, some February years ago. And you can see that every day, okay, that right around 6 a.m., the temperature reaches its lowest, and then it rockets up into the afternoon at its highest. So this makes sense. People have experienced this. Of course, this is due to the rotation of the Earth and the changing sun angle during the day. As the sun angle gets higher and higher, you get very high inputs of solar radiation, shortwave radiation, and that causes the ground to heat up. The ground heats the surface above it, and the air temperature warms up. So you see this classic up, down, up, down, up, down during the course of a day, night, day, night, day, night. This graph here would be called a temperature meteogram. Now, interestingly, you see the difference between the high and the low. That's representing the daily temperature range. You already learned about that in your notes. So this would be a very high daily temperature range. And then something over here, something happened to create a much lower daily temperature range. Probably it got really cloudy over here. Over here, it was probably fairly sunny. That's a common thing, or I should say clear skies. So I want you to notice when you look at data like this, a high daily temperature range over here, a very low daily temperature range over here. What's daily temperature range? The difference between the highest and the lowest, maxed minus min. And again, the main thing is the rotation of the Earth on its axis. It takes one full rotation, one spin on its axis over the course of 24 hours, and that causes any given place to have sun angles change during the day. They start out, of course, at zero, no sun in the morning, and then it rises, the sun angle gets higher, it peaks, and then at some point it gets lower. Now, as we look at daily temperature range a little more closely, these graphs are really helpful to consider the idea of radiation. So remember, the sun gives us shortwave radiation, solar. Earth gives off long-wave radiation, or some people call infrared. So simplest way to think about it, here's the time of the day, is here the yellow lines are the inputs to Earth. So we add the inputs and then we subtract the outputs. This is the long wave lost from Earth. And when you compare the two, you either have more coming in or you have more going out. Well, whenever you have more coming in, that's called a surplus. We briefly talked about this before. A surplus will heat the surface then heats the air. So a surplus, when the inputs exceed the outputs, that leads to heating. And then when the outputs exceed the inputs, when you're losing more radiation than you're gaining, that leads to cooling. So interestingly, what you see here is, of course, the highest inputs are right around noon. But it keeps warming till about 3 or 4. Well, why is that? Because you still have inputs that are higher. So that you see the yellow line is higher than the red line. Well, the inputs are decreasing and decreasing, but they're still higher. They're decreasing, and then generally right around late afternoon, 3 o'clock or 4 o'clock. There's a lot of different factors. What is it that happens? Usually that's the hottest part of the day. Notice the graph down here. Very commonly, that's the hottest part of the day. But why does it then begin to cool? Because the outputs have finally exceeded the inputs. So the red line on the graph here is now higher than the yellow line. That's called a radiation deficit. When you're losing more radiation than you're gaining, that leads to things starting to cool off. So this is really all about comparing the inputs and the outputs. So just keep in mind, the inputs of solar radiation are highest right around noon, but the overall surplus continues until about 3 o'clock, when finally the outputs get higher and things start to cool off. And then what do? They cool off all night. So you notice, of course, the solar radiation drops to zero, nothing, when the sun goes down, but you continue to lose long wave infrared all night until you reach a time right about sunrise or a little after sunrise, when your deficits, when your cooling has continued and gone on, and you hit the coldest part of the day. Why does it start to warm up? Because right about there, the inputs now exceed the output. So I want you to think about these, think about comparing these. So that's what's really happening during the course of a day. One more little item in your notes before we move on to the next thing is annual temperature cycles. So just real briefly, what you see here for a number of different latitudes, and we'll talk about latitude in the next video, but for a number of different locations on Earth, you see the annual change in temperature. And so, of course, what is happening, this is St. Louis, Missouri, Winnipeg, Manitoba in Canada. This is Point Barrow, northern Alaska. And down here you have months of the year. Okay, I literally once had a student ask me what the word Jiffamam-Gisond was. And you see here, Jiffamam-Gisond, well, that's the months of the year, January, February, March, and so forth. And so what do we see? You see temperature in Celsius over here, temperature in Fahrenheit over on the side. And of course, you see in traditional summer months for the Northern Hemisphere, roughly July is most common, the temperature reaches its peak. Okay, and then of course, as the months go on, August, September, October, November, December, January, the temperature reaches its minimum. So different locations on Earth have different annual patterns, but what is changing? Excuse me, during the course of the year, the angles and hours of sunshine change, the angles of sun in the sky and the hours of sunshine per day. And then you throw in a couple of wild cards, which we will talk about. Cape Town, South Africa. Notice that their coldest month is in June, July, which is totally different than ours. That's the southern hemisphere. Their warmest month is when? December, January. And then you have this spot in Peru, which hardly changes during the course of the year. So what would this purple line for Peru, what would I call that? A very low annual temperature range. The highs and the lows during the course of the entire year, the difference is very small. What about Winnipeg, Manitoba, or Point Barrow, Alaska? This is a very high annual temperature range. The highs are very high compared to the lows. The difference is the annual temperature range. So we'll talk more about latitude in the next video. Thanks for your valuable time, and go forth.